Hello, good evening, and thank you for your patience tonight. I'm NASA Press Secretary Jackie McGinnis, and we are just 2 days away from our next opportunity to launch the Artemis 1 flight test to the moon. Artemis 1 launch is currently scheduled for Wednesday, November 16th at 1:04 a.m. It's a 2-hour launch window, and we currently have a 90% chance for favorable weather. The mission management team met today to review the status of the mission, and joining us here at Kennedy to provide you all with an update is Jim Free, Associate Administrator of the Exploration Systems Development Mission Directorate, Artemis Mission Manager Mike Serafin, Artemis Launch Director Charlie Blackwell-Thompson, Chief Flight Director Emily Nelson, and U.S. Space Launch Delta 45 Weather Officer Melody Levin. If you have questions, please press *1 to enter the queue, but first I'll give each of our participants an opportunity to provide an update. So Jim, over to you.
Thanks, Jackie. Thanks for hanging in there with us tonight. Appreciate your patience as the team worked through the MMT. There's been a lot of work to get here, as we've talked about, as some of which I just shared on Friday, and the team here at KSC and really the engineering team for all the vehicles continue to work to press towards Wednesday's launch. Continuing to work things post-hurricane, continue to work the normal prep stuff, and you'll hear about that. And as I talked about on Friday, and we've continued to talk about, there is more risk as we on this uncrewed flight test as we really stress our systems around the moon, and to learn as much as we can about the vehicle. And the MMT today in prep for that mission work through some of the outstanding items, even going back and cataloging some things that we found in our other launch attempts. But we're still pressing towards a launch attempt on Wednesday, and I'll let the others talk about the details of what stands between us and Wednesday. I do get the pleasure of, I guess, announcing publicly that we received confirmation that Capstone arrived in near rectilinear halo orbit, and that is a huge step for the agency. It just completed its first insertion burn just a few minutes ago, and over the next few days it will continue to refine its orbit and be the first CubeSat to fly and operate at the moon. This is a very important orbit for us here on the Artemis program, specifically because that's where we will fly Gateway. And as Capstone flies in that orbit for about 6 months, we'll get more data to understand and characterize that orbit. And in addition, Capstone carries a navigational tech demo that will help other spacecraft operating around the moon. So, as we press to Wednesday, we already have our first effort going on at the moon in Capstone, and press towards our challenging journey that we have and this difficult mission that we continue to prepare for carefully and patiently, because we want to take as much risk out of the system as we can, but there is risk in there and we need to be prepared for that. So for me, it's great to watch the entire group of people across the government, across industry, across international partners really adapt and problem solve over the past several months, and my faith in their judgment and the decisions that we've made as a management team is really unwavering. So with that, Jackie, I'll turn it back to you.
Mike, over to you.
Okay, good evening, and thank you for continuing to follow our preparations for the Artemis 1 mission. Today we conducted our launch -2 day readiness review with the mission management team. That was essentially a Delta launch readiness review since our last launch campaign. It was a fairly lengthy meeting. It was about a 4-hour long meeting, and during that we reactivated the mission management team and we reset our baseline headed into this launch campaign and targeting a November 16th attempt. We reviewed our launch windows and just overall readiness of the operations teams, our facilities, the rocket and the spacecraft, just all the changes that we've had since, again, the last launch campaign. We reviewed some issues, some of which have been retired several weeks ago, but some are relatively new as a result of the Nicole and the storm that blew through here earlier in the week. We reviewed our vehicle configuration from the top of the rocket, or the top of the spacecraft all the way to the bottom of the rocket, including things like the flight termination system, the batteries that we've reset, the payloads that we've reset. All the mission management team members polled go, headed into the November 16th launch attempt, pending one open action and two open issues. The two issues that got the most discussion pertain to storm damage or suspected storm damage as it relates to Nicole. And the first was on the liquid hydrogen tail service mast umbilical. We have a suspect electrical connector on the tail service mast umbilical that carries some information that is used to confirm a subset of the launch commit criteria on day of launch. We do have redundant signals that are used to confirm those launch commit criteria, but the team is trying to restore us back to a normal baseline through some work tonight out at the launch pad. The other open item and the action that pertained to the meeting today that came out of today's meeting and is going to cause us to get back together for a launch minus 1 day review has to do with some room temperature vulcanization, or RTV, material that has delaminated from the eastern side of the Orion spacecraft, where the launch abort system's aerodynamic shell, called the ogive, meets up with the crew module adapter. And this RTV material delaminated during the storm, and we need to just spend a little more time to review our flight rationale headed into this launch attempt, specifically as it pertains to liberation of any remaining RTV and debris transport. So we're going to get back together tomorrow as part of that. As a reminder, our mission priorities for Artemis 1. Priority 1 is to re-enter the vehicle at lunar re-entry conditions. We need the rocket to do its job and deliver us to the point of translunar injection before the spacecraft takes all that kinetic and potential energy out in the form of aerodynamic drag and heat during the direct re-entry from the moon. That's priority 1. Priority 2 is to operate the vehicle in the flight environment. That's all the way from liftoff through the point of translunar injection out into the deep space environment as we fly out through the Earth's Van Allen radiation belts, out through the micrometeoroid and orbital debris field, and then re-entry back into the Earth's atmosphere and splashdown. Priority number 3 is to retrieve the spacecraft for programmatic cost savings, to retrieve the data on board, and then just to have the vehicle for engineering tests post-flight. And then priority 4 is what I like to call bonus objectives, things like payload objectives, and then to share the mission with each and every one of you from liftoff out towards the moon and then back to Earth reentry and splashdown. So as we went through the mission management team meeting today, we reviewed the changes from our technical baseline established, our risk baseline established at the agency flight readiness review in the context of those mission priorities, discussed the likelihood of our success as well as any delta risk to our prior baseline, and that is the role of the mission management team. So I feel good headed into this attempt on the 16th, and we're going to get together tomorrow to review some of our flight rationale as it pertains to that one open item on some Orion RTV. So with that, I'll pass it back to you, Jackie.
Thanks, Mike. And now we have Charlie Blackwell-Thompson.
Well, good evening, everyone. It's my pleasure to be here to talk about our preparations for launch coming up here in just a couple of days. Let's see, these past few days, our team has been working hard to finish up the inspections that followed Hurricane Nicole. As most folks are aware, we had a ride-out team that was in the Launch Control Center throughout the duration of the storm and kept a close eye on the Artemis rocket. We had imagery data, we had wind data, and we had additional instrumentation that was on the SRB hold-down bolts as well as the vehicle stabilizer. And so we had all of that information along with the ground systems data that the team was monitoring during the storm. Once we were cleared back into the center on Thursday evening, the ride-out team was released, and we began doing an eyes-on assessment of the flight vehicle as well as the ground systems. We noted we had several things of note that we have worked our way through, and some that Mike just mentioned today that came to the mission management team. Since getting back into the pad, in addition to the vehicle assessments and working through the items as noted, we've also began our preparations for launch. We had about 24 hours of launch countdown preps that remained. We had worked a number of our preparations for launch prior to securing for the storm, and we picked up with those upon reentry. On Friday, we performed a confidence test of the vehicle. We powered up all of the vehicle elements, and we found that all the vehicle data was nominal. As Mike said, we did receive, during the course of the storm, we had a measurement that we noticed, it was a ground measurement, that we saw a little bit of what we thought was noise on that particular measurement during the course of the storm, and we did some additional troubleshooting on it afterwards. That measurement was actually on a primary or secondary main pump RTD, or a heater, essentially, that comes through the LH2 TSMU, the teleservice mast. It's what we call J8. It's a connector there. It's on the bottom of the plate. And we noticed that there were a couple of measurements that exhibited some of the same phenomena. So the team has been troubleshooting that over the course of the last day or so, and we replaced a ground cable. We did see some improvement in the measurements, and all of them came within our LCC, our launch commit criteria band. But we still noticed that they were a little bit different than what we expected. So tonight out at the pad, we are preparing to replace what we call the feed-through connector, which is the connector on the back of the plate. And we'll go do that this evening, and then we'll do a retest, and we expect that this will remedy the problem, but if not, then we'll certainly follow the data as we always do. So let's see, that is the only issue from a ground systems perspective that we're really tracking. We are on schedule to do our launch countdown call to stations tomorrow, but it's actually, just a few hours away at 01:24 this evening, and we're excited for that, and our countdown clock will begin counting at 02:04. Since we were last together, there hasn't been any significant changes to our launch countdown other than you may recall when we had launch countdown attempt number 2. Following that, we went through and looked at our LH2 loading, and we did change that just a little bit so that we would start that loading earlier, and we would do it in what we refer to as a kinder, gentler method, where we utilize the storage area sphere, the pressure there, to gently increase it to load the vehicle. So when you reduce the pressure and the flow rates, it takes a little bit longer to get that big tank full, and we incorporated that into our loading timelines. We demonstrated that during our cryo demonstration, our tanking test, and that all went very well. So we've incorporated that into our timelines, and we are scheduled, I will give you the times here. Our tanking time, our go for tanking is at 15:24, and then we will start our LO2 chill down around 15:44 on Tuesday, so in the afternoon, and then the LH2 chill down starts right around that same time, about 15:44. Sometimes folks are interested in when we're going to do that LH2 engine bleed kickstart, because we know that previously that was where we had seen some leaks when we put some pressure into the system, and that'll be at 17:27 local time. I will say that when we went through that process as part of our tanking event, it all worked very well. So after our tanking, we will do our 90 minutes of range safety checks. We will count down the T-minus 10-minute hold. We will do our final polls to resume the count, and then we'll get into terminal count and then count down toward an 0104 Eastern Time launch.
Thanks, Charlie. Now we'll hand it over to Emily Nelson.
Good evening. All the teams in Houston are looking forward to the launch this week. That first day of the mission promises to be a very exciting day. Shortly after liftoff, the MCC team in Houston is going to take over from Charlie's team here at Launch Control. For a launch on the 16th, that mission is going to last about 26 days. That very first day has an awful lot of activities on it. We'll have the boosters separate from the core stage just a few seconds after launch, and then within about 10 minutes, the core stage itself will have finished, and it'll separate. Then at about the hour-and-a-half mark, the interim cryogenic propulsion stage, we call ICPS, will fire the translunar injection burn, we call TLI, and then separate from Orion shortly thereafter. At that point, we'll begin a number of checkouts of including the Orion engines. We'll do a short burn to make sure that Orion is burning correctly, and then several days later, we will begin the series of burns to achieve the distant retrograde orbit around the moon. Along the way, we'll do a number of checkouts of the various Orion systems, calibrating sensors, capturing some fairly unique imagery, etc. Once we get to the moon, we'll stay in orbit about a week, and then we'll begin a series of burns that will swing us past the moon again on our return to Earth. As Jim noted, this is a test flight. We anticipate learning a great deal as we take the spacecraft, this first spacecraft designed for humans, farther from Earth than any of our previous human-rated spacecrafts have been. We're prepared for any number of types of failures. We have predefined alternate missions to accomplish as many test objectives as we're able to in all cases. Our ultimate goal is to test SLS and Orion to ensure that we're ready for crew members on our next flight. I'm sure we're going to find some surprises along the way, and our teams are ready for what promises to be an exciting mission.
Thank you very much. And now over to you, Melody.
All right, good evening, everyone. Well, I have great news to give everyone. The weather looks really good for launch, so that's something I haven't really been able to talk about in quite some time, so I'm happy to share a happy forecast with everyone. Today, we did have a cold front move through. It is currently positioned south of the spaceport. We did have some showers and thunderstorms roll through, but right now, most of the showers are positioned south of the spaceport. We do have some breezy conditions currently and dropping humidity behind that frontal boundary, so that will certainly make things comfortable. The wind will begin to veer onshore tomorrow, so we may have some coastal showers just likely staying near or slightly offshore, so we'll be watching those for tomorrow. But in general, the weather should be favorable for any outdoor operations that the team needs to get done. On Tuesday, we will be in a prefrontal regime, but generally speaking, the flow should become more offshore in nature during the time of tanking and also during the launch window. That's very good news because that should keep those coastal showers far away from us and that threat low. So because of that, I have given a 10% probability of weather violation. That translates, of course, to a 90% chance of favorable weather during the launch window early Wednesday morning. Temperature should be near 70 degrees with winds out of the south-southwest, pretty steady at 10 to 15 knots, up through 200 feet. Back to you, Jackie.
Thank you all very much. And now we will open it up for questions. As a reminder, if you'd like to ask a question, you can press star 1 to get into the queue. First up, we have Marcia Dunn with the Associated Press.
Hello. For Jim and or Mike, how much Orion RTV is actually delaminated? I don't know if we're talking a couple inches or a couple feet or even more. And a bigger question, if I might, with each delay, whether it's fuel leaks or hurricanes, the stakes seem to get ever higher for this first Artemis flight. And I'm wondering if that's ratcheting up the stress level for everyone, and how crucial is it for this first test flight to go well in your view? Thanks.
Okay, yeah, Marcia, this is Mike. We did talk about the amount of the RTV that came off of Orion at the base of the ogive and the top of the crew module adapter, and it was an area that was about 10 feet in length and was centered on what we call the 270-degree location relative to the Orion structure. But that was basically the windward side where the storm blew through. It is a very, very thin layer of RTV. It's about 0.2 inches or less. That it's like 0.2 to 0.1 inches in thickness. You know, we know that it came off in pieces, and there's just this one zone. In terms of stakes, you know, I'll let Jim add anything he wants here, but you know, we're working through this methodically. We understand what the risk baseline is for this uncrewed test flight, and we've shared from the get-go that we know that there's a fair amount of risk with this particular initial flight test of the SLS rocket and the Orion spacecraft. It is a purposeful stress test to buy down risk, as Emily indicated earlier, for crewed flight. So we have a deliberate lean-forward strategy to help buy that risk down. The vehicle needs to fly through the same flight regime and flight environment and same flight profile, whether we launch this coming week or a month from now. And we do keep in mind that we do have a host of other systems in play that have limited lifetime on those, but we do reassess those, and we did reassess those headed into this launch campaign, and we got an update on those. So I would just say that, you know, the stakes are you know, what they were coming out of the agency FRR, and we continue to review those. So, Jim, if you have anything to add to that.
I think you actually hit on one of the things that I wrote down as I was thinking about the question. The stakes are the same. Somebody said to me last week, you know, this core stage is no stranger to named storms. They started when it was at Michoud, they went when it was at Stennis, and now it's continued here at Kennedy. I think, as the administrator said after our first launch attempt, you know, we're going to go when we're ready. We're learning the systems of this vehicle. We continue to do that. And I said on one of my earlier calls, or I think actually press face-to-face, you know, the individuals that work on this program are people, and but they're professionals, and they understand that systems are going to take some time to learn. They, of course, would like to see it fly, so we learn about it, so we continue down the path to Artemis 1. But ultimately, they're professionals, and they'll do their jobs, and the stakes are the same, as Mike said. We need to do this, accomplish our 3 objectives, get the vehicle back, being one of them, and move on to the next launch.
Thank you very much. Next, we have a question from Kristen Fisher with CNN.
Thank you all very much for doing this. My question is, obviously this press conference tonight was delayed quite a bit by a little over 90 minutes. Wondering if you all could just give us a bit more insight into what specifically caused that delay and what level of dissent there may have been within that meeting about some of the issues that this rocket still faces. Thank you.
Yeah, hi, Kristen. This is Mike Serafin. So as the chair of the mission management team meeting, you want to give folks time to speak their mind and get all the information on the table, and you know, have whatever hard conversations are necessary. In terms of the delay, I would attribute that mostly to 2 topics. One was the suspect electrical connector on the tail service mast umbilical at the one particular data port or outlet that Charlie referenced earlier, which is called the J8 location. That is a relatively new issue. You know, we just got the information that we had a problem on Thursday of this week, of this prior week, relative to that particular issue, and then we had to wait to gain access to the center and the pad, and the team is still working their way through that one. So I would classify that as an emerging issue, both in terms of understanding root cause, but also in terms of understanding what the impact is to the mission. We're farther ahead in terms of understanding what the impact is to our launch readiness, but we still need to get access to that particular connector, and the team is working that tonight. So we talked through the removal and replacement plan, the inspection plan, and what testing was required relative to the timeline to set up for the launch attempt on Wednesday. So that was a lot of new information for the team to walk through and process and really work through, because we didn't have the luxury of having our offline technical forums headed into today or this evening. The other topic was the Orion RTV topic, and that one we talked through what we knew and what we didn't know, and we had a fairly lengthy conversation about we have more unknowns here than we have knowns, and we need to methodically step through our flight rationale and use an approach to basically capture the unknowns relative to risk, and the risk in this case is the debris transport. The Orion spacecraft is further up the stack, and we need to understand what this particular material type, its density, and whether there's additional material that could be liberated during the launch phase. So again, that was storm related. We just knew about this on Thursday and Friday as we started getting information in from the post-storm inspections. Recall the storm blew through just 3 short days ago, and we've had a lot of new information come through. The rest of the systems checked out. We did talk through those. All of the vehicle health and status checks, all of the systems on the ground side or the spaceport and here at the Kennedy Space Center largely checked out. There were a few minor things that the team recovered from, and we talked through those. But when you put a storm in front of you or now behind you, and you want to resynchronize the team so you understand your risk baseline, you got to talk through those issues that are relatively new and emerging. But you also want to revisit changes since the last time you got together, and we spent the time to do both of those things today. I anticipated that this would be a long meeting. I thought it would probably be about 2.5 hours. And when our lead public affairs officer, Catherine, asked for what my thought process was on how long that meeting would be, that's what I told her. I underestimated how long it would take to get through this. So you can fault me for underestimating the amount of conversation this would have. In terms of dissent, I would say there was no dissent. All the MMT members polled go, but we do have some work to do. There were various discussions on how we could most efficiently work through this Orion RTV loss issue, but for the most part, the team is moving forward as one unit. We just got some work to do. So I hope that answers your question.
Thanks, Mike. Next, we have a question from Bill Harwood with CBS News.
Hey, thanks very much. Hey, Mike, just to continue along that line, a couple of questions. They're all related, but it's more than one. But how much material are we talking about that could possibly get liberated? Is it repairable at the pad? And I realize this is an unpiloted flight, but how is this different from the shuttle program opting to continue flying? When ramp foam came off and did an SRB, electronics assembly in late 2002. I mean, when people start talking about transport mechanisms on some kind of insulation, it automatically, gets antennas raised up. Just curious how you view it in that context. Thank you.
Yeah, Bill, as you're well aware, I work the shuttle program, and I understand the context you're providing. How much RTV? This RTV essentially encircles the base of the ogive where it meets the crew module adapter. So it's the entire circumference of the Orion spacecraft, and it's a thin band. I would say I'm estimating that it's a couple inches wide. It's very thin. It's up to 0.2 inches thick, and it's the entire circumference of the spacecraft that we're talking about. In terms of repair, we do not have access to repair this at the pad. It is way up the stack, and we don't have access around the entire circumference out at the pad. And then in terms of difference with the shuttle program, it is a fundamentally different vehicle design. The shuttle was a side-mounted spacecraft on the side of the rocket. Now, the vehicle in this case is taller, and we do need to take that into account. But in terms of hitting critical components through debris that's liberated and then transported further down the stack, the physics are the same. The analysis is very similar, but where components and critical components are located are just fundamentally different. So we take that into account, and we look at all that through our risk analysis and risk assessment, and then debris transport process that we have.
Thanks, Mike. Next, we have a question from Joey Roulette with Reuters.
Thanks, Jackie, and thanks, guys, for doing this. I guess this is for anyone who wants to answer. Was the flight rationale meeting that you guys have scheduled tomorrow, I guess, specifically to discuss the delamination RTV issue, or was that part of the meeting that was going to happen anyway? And also, do you think there's a chance tomorrow that you'd maybe want to run through the countdown as kind of like a rehearsal, even if you'll have to scrub for the next opportunity, just, I guess, to see if there's any other kind of issues? Thanks.
Yeah, Joey, I'm not sure I'm following the second part of your question about the chance for tomorrow. Can you repeat that?
Yeah, I guess is there a chance you guys might want to just run through the countdown as some kind of like rehearsal if you maybe run into something that will preclude a launch opportunity for that day? Just, I guess, to keep as a practice run or something, I guess. I don't know.
Okay. I'll take the first part of that question about the L-1, and then Charlie, you want to take the second part about the practice for tomorrow. So, tomorrow we would normally have as a day of rest for the team. There is this one very specific issue associated with the RTV on the Orion spacecraft that we recognized today that we needed more time to review, and there is delta risk acceptance there, but the flight rationale, it just wasn't quite ready for disposition today at the mission management team. Again, it's a very new issue. It is something that we became aware of on Thursday and Friday of this week as we did the inspections of the vehicle out at the pad, and then the team started to identify that there is delta risk acceptance here, and then started to work the flight rationale. They flagged it, which is absolutely the right thing to do, and then they brought it forward to us, acknowledging that there is additional risk here, but in terms of the MMT saying that this is accepted and put behind us, we weren't ready to do that yet today with the information that was provided. So we will take extra time to do that, and we will get together tomorrow to ensure, after the team has had a little bit more time to do that, that we understand the delta risk. With that, I'll turn it over to Charlie on the practice question.
Well, let's see. I would offer that we've had an opportunity during our tanking test to go through and practice our loading and our loading ConOps timelines and software. So I'm not sure that there would be a significant benefit from going through a loading operation. Certainly it would be, our preference that as we work through this issue, and if we decide that we're in an acceptable configuration to go fly, that when we go tank, that we would that would be on our launch day, and that we would preserve the maximum number of launch attempts within this launch period to try to get off the ground.
Thank you both. Next, we have a question from Irene Klotz with Aviation Week.
Thanks, Jackie. So on the RTV, what could it possibly hit if there was additional delamination? And I guess I'm not really understanding what the purpose of that is. If the only issue, if it's not there, is that it become a debris issue. And then regarding the electrical connection on the TSMU, if replacing the feed-through connector doesn't clean up the signals, is that a showstopper? Do both that and the backup systems need to be in your kind of optimal configurations before you'd go ahead as a part of the launch commit criteria? Thanks.
Yeah, Irene, Mike Serafin, I'll take first crack at that, and then Charlie, you can add anything you want. But in terms of what could the RTV on Orion hit, obviously the aerodynamic shell that we call the ogive is near the very top of the stack, so we need to look at anything that is downstream as the vehicle accelerates up, and if debris is liberated or items are lost, the RTV is lost as the vehicle accelerates through the Earth's atmosphere, it could get out into the airstream. Then the airstream will essentially slow it. It's like sticking your hand out of a car window as you're going down the highway. The air is going to grab it and slow it down, but the car is still accelerating down the highway. So we need to consider that phenomenon in this case. So anything that's downstream of Orion and the early flight phases up until we do booster jettison, as well as the bulk of the atmospheric flight, includes the boosters themselves, as well as the interim cryo propulsion stage and the launch vehicle stage adapter. We're really not worried about the launch vehicle stage adapter. It is a very robust piece of hardware. The interim cryo propulsion stage has a few systems tunnels or just aerodynamic protrusions where some equipment is run up the side, and then the boosters themselves, the nose cones and the attach points are areas that we all need to look at. So those are the things that we need to look at relative to the RTV that could be liberated from the base of the ogive on Orion. In terms of the TSMU connector, I personally don't consider that a showstopper given the information that was presented. We do have some very well-written launch commit criteria that are very well thought out, and in the cases that we're talking about, the signals that come through require one of three signals to be go for launch, and these signals are routed through different connectors. So it's only this one specific connector that has a signal, and even if those signals are out at that connector, we would still meet our launch commit criteria. Again, given the pre-planning that our engineers have done, and right now there's no reason to deviate from any of those launch commit criteria. They're very well written, and they would support flying in spite of what this connector may bring. That said, we're hoping to get us back to a fully functional capability. So, Charlie, if you have anything to add to that.
No, Mike, I think you covered it. We always like to have redundancy, but when we write our launch commit criteria, we write them for what is required to go fly. I would also point out that these are utilized for the thermal conditioning in preparation for the auxiliary power unit start. So they're not used to fly the vehicle. It's not part of the onboard software. They are in place for the APU start. And as you said, we have redundancy, goes through different connectors, and would have a reduction. We would go in the event that we are unable to get this corrected, we would go in with a loss of redundancy. But it is per our existing launch commit criteria.
Thank you very much. Next up, we have a question from Eric Berger with Ars Technica.
Hi, thanks very much for doing this. Question for Mike, I think, just to follow up on what Irene said about the RTV. What is the purpose of this material? I understand it's probably difficult to work with, but are you concerned about an installation or thermal problem if more of it peels off during launch, or just sort of want to get some understanding of your confidence of why, what you've seen there is not a concern in terms of mission performance? And then just as sort of a broader question about this rocket sitting out in a hurricane and then launching a week later, that strikes me as really pretty impressive and speaks to the robust design the vehicle. Can you recall any time with the space shuttle that it sat out in a storm like this and then was able to launch in such a quick turnaround and by staying at the pad? Thanks very much.
Yeah, Eric, thank you for the questions. The purpose of the RTV material is, well, first of all, it is a standard aerospace material. There are lots of applications on lots of spacecraft that use this particular material. It is not difficult to work with at all, in many cases, you could kind of think of it as a caulk to fill in a space. And at the particular location, the particular application that we're talking about, at the base of the ogive, where it meets the crew module adapter, there is a little bit of an indentation that goes around the circumference of the Orion spacecraft, and the purpose of the RTV is literally to fill that in, because otherwise it creates a little aero protuberance. In this case, it's actually not sticking out in the airstream. It's actually an indentation away from the airstream where you could get a little circulation of air, and in certain flight regimes create aero heating. That said, we do have protections in place as it pertains to the materials that underlie that RTV. This is just an additional layer on there to create a kind of a seamless airstream flow as air comes over the ogive. In terms of the turnaround in the shuttle program, I know that we've had some short turns in the program, but nothing immediately comes to mind. And I'm looking at Charlie, and he and I worked a fair number of missions together, and I don't know, Charlie, if you've got any that come to mind. I mean, I know we turned a couple of weeks between launches, but I can't remember anything that was storm-related that we turned on the matter of days.
Yeah, nothing comes to mind, but we could certainly go back and look through the shuttle history and see if there was something there and get back to you on that. But I don't know off the top of my head.
Thank you. Next up, we have a question from Chris Gebhardt with NASA Spaceflight.
Hi, yes, two for Charlie. One, I'm wondering how many cutouts are there presently in the 2-hour window on Wednesday morning, and about how long are those? What's the longest one that you know of in there? And also a question to the countdown itself. When you get to the T-minus 33-second mark, I was reading today from some NASA documents that any cutoff of the count after 33 seconds is an automatic, no questions asked scrub for the day, regardless of what the reason is. So I'm just curious, why is 33 seconds a hold point, but 32.9 seconds an automatic scrub if you have an issue, even if it's not a technical issue? Thank you.
Yep, so let's see, I'll start with the cutout question first. So we will get our final launch window cutout report on launch day. We'll get an update at L-2 as well later. But the one that I have from a couple of days ago is we have about 56 cutouts as part of our, during our launch window. Most of them are just a few seconds long, but we do have a few that are a couple of minutes. And then let's see, why 33 seconds? So 33 seconds is the point at which the ground launch sequencer hands over to the ALS, which is the onboard flight software. And if the onboard flight software detects any out-of-limits conditions, then it will cut off and go into a safing mode automatically. And that's just the way the flight software was built.
Thanks, Charlie. Next, we have a question from Andrea Leinfelder with the Houston Chronicle.
Hi. I was hoping that, Mike, you could just explain the open action, the open issues in a bit more layman's terms. Our audience is not quite as technical. And also, I'm sorry, this is a question for me. What's the difference between an open action and an open issue? Thank you.
Yeah, hi, Andrea. And action is, we've asked the team to do something very specific, and in this case, you know, again, the role of the mission management team is a risk acceptance body and a risk management forum. Open issue or open work is something that we just need to go do. We believe that there's a path forward. It is not yet resolved, and we need the team to go off and work that. So I hope that answers your question.
Next up, we have a question from Emery Kelly with Florida Today.
Hey, folks. Good evening. Just real quick, are there any possible theories about what may have caused the RTV issue? Could it be the direction of wind from the hurricane as a possibility? And just real quick, second part, if this were Artemis 2, if there were astronauts on board, would this RTV issue be a showstopper? Thanks.
Yeah, again, Mike Serafin here to answer your question. So the RTV was lost due to wind and potential rain from the Hurricane Nicole. It is on the windward side of the vehicle, and it faces the easterly direction that the winds were coming from relative to the storm and landfall. And then relative to, again, Artemis 2, if this were a crewed flight, we would be having the same conversation relative to our readiness to fly, crew on the next mission. Do we understand the risk, and is the risk acceptable given all the variables in play? But as I've noted earlier, there's a whole host of things that are presumed in that question, and flying crew on Artemis 2 presumes that we had an outcome on our uncrewed test flight that meets just our overall ability to fly with confidence that we can safely fly crew to the moon and back on the next mission. So it presumes that we're successful on this uncrewed flight test, and we've got to get through this test flight first, and we are going to learn things from it, and we are going to adjust our approach and potentially need to adjust some operations or systems relative to flying crew on the next mission, which is why we have this purposeful build-up approach and this purposeful flight test strategy where Artemis 1 is uncrewed leading to a crewed flight. And then Artemis 2, crewed flight test, leads to our goal of putting the first woman and the first person of color on the surface of the moon. So, it's not an easy question to answer relative to would we accept this risk on Artemis 2. We haven't even accepted it on Artemis 1 because we're still working our way through the flight rationale. But we would have some very similar conversations relative to flight readiness.
Thanks, Mike. Next up, we have a question from Nicole Mortiaro with the Canadian Broadcasting Corporation.
Hi there. Yeah, Nicole Mortiaro from the CBC. Mike, you pointed out that Nicole, no relation, was 3 short days ago. So is there any concern that, God forbid there is an anomaly with the launch, that it would be difficult to ascertain if it was due to hurricane damage and, for example, the RTV issue, or some sort of issue with the rocket itself? I mean, why launch now rather than under better conditions?
Well, thank you for the question. That is something that we've spent considerable time and data analysis reviewing. Charlie and her launch operations team have gone through a series of systems checks, vehicle engineering tests, and data reviews, as well as image reviews and walk downs of the launch pad. And all of that data and that information tells us that with these 2 exceptions that we've noted, the faulty connector on the tail service mast umbilical, and with the RTV on the Orion spacecraft that's delaminated, all the other systems check out. So we've put a lot of work over the last couple of days, and we've got great tools, and we've got engineers and operators that are trained to go through this information very quickly. In fact, they're trained to go through it in a launch countdown, in the terminal launch countdown, as well as in Houston while we're actively flying the vehicle. I used to be one of those people where you have trained scan patterns and you know exactly what data to look for to tell yourself as well as your operations leader whether or not you've got an issue that requires action or to stand down on a launch attempt or a flight operation. So all the data right now is indicating we have a healthy rocket, a healthy spacecraft out there with minus these two issues, and we're off working those. And I don't know, Emily, if you have anything to add to that one.
No, well said.
Okay. And Charlie, anything to add to that one?
Okay. Nothing additional.
Well, then we'll move on to the next question. Next up is Micah Maidenberg with the Wall Street Journal.
Hi there. Not sure who this would go to. Just real quick, is there any update on the root cause of the relatively large hydrogen leak in the second attempt? What caused that? Thanks.
Yeah, Micah, Mike Serafin again. You know, we did go through the fault tree for the hydrogen leak. We could not definitively say what the root cause was, but we did isolate it to less than a handful of potential causes, foreign object debris, and a couple of other causes on that fault tree. And we've put a series of mitigations in place. Thermal shock was another one, and then potential for moisture were all on the fault tree that we looked through. We took all the actions that we could to mitigate it. We replaced the seals. We tested the seals under a cryo demonstration, and we modified the loading operations to reduce the pressures, as well as to slow the thermal shock through this kindler and gentler loading operation. We automated as much of the operation as we could, and then we went off and trained it to ensure that we were ready for the operation. So sometimes you just don't get to a singular root cause, and this is one of those cases. That said, we did as much as we could, and we're comfortable with the posture headed into this next campaign.
Thanks, Mike. Next up, Clayton Sandell with Newsy.
Hi, guys. Thanks for doing this. If the consensus is that you cannot launch until this delamination-related repair is made, I assume that means rolling back to the VAB where you can actually get access to it. And I was hoping you might give us an idea of just how complicated a repair this might be and how it might affect the timeline going forward for other launch attempts. And also, Mike, you mentioned other systems in play as having a limited lifetime, and does this cause a problem for you there? Thanks.
Yeah, Clayton, you know, I think that's like we're focused right now on getting to this launch attempt. Obviously, we have a lot of data from when the RTV went on. You have to put it on, you have to let it cure. So that takes time. A lot of that work was done in the launch board processing facility. A lot was done in the VAB. I think we have a lot of understanding of the process, but it does take time. But I think we're way too early to have conjecture on what would happen if we rolled back. How long would it take? You know, if the team comes back, their action for tomorrow is to assess the impact of the RTV as it is today, and if we were to launch. If the decision is to do something different, then we'll address the forward plan. But what I really want them to be focused on right now is heading towards that meeting tomorrow, and the rest of Charlie's team focused on processing the vehicle for launch.
Thanks, Jim. Next, we have a question from David Denault with About Space Today.
Thank you. Part of my question's already been answered, but no one's talked about the weather. And in weather in Florida, it can always be different. So how about a weather report, please?
All right. Well, you must have missed my first weather report, but basically the weather looks excellent for launch. This is actually the best forecast I've been able to produce for the team since we've been trying to attempt to launch. So 10% probability of weather violation, which is a 90% chance of favorable weather. Temperature near 70 degrees. Winds out of the south-southwest at 10 to 15 knots.
And David, I was just joking with Melody that is an imperfect weather forecast right there, meaning that we're 10% no-go. So I just thought I'd add that on at the end.
Thank you both very much. We're coming up on time, so we have time for one more question. We'll hand it back over to Irene Klotz from Aviation Week to close this out.
Thanks. If it turns out that you need more time to develop the flight rationale, are there other dates before the 19th that might be discussed with the range, or would it go from the 16th through the 2 to the 19th directly for launch attempts?
Let's see, Mike, I'll take a shot at that one. As a launch director, anytime we don't make a launch or we need additional time to go assess things, we'll always go look at what that next earliest possible opportunity would be. Currently, we are on the range schedule for the 16th with our backup date of the 19th, but our turnaround plans require about 2 days between launch attempts. So certainly we would go explore all possibilities to look at what was in the art of the possible for additional launch attempts, either by moving a day or looking at opportunities in between where we are currently scheduled.
Yeah, and Irene, the only hard constraints we're tracking here kind of in the near term are that we have eclipse violations on the 20th and the 21st of November. The rest of the dates are within the art of the possible. We'll see where we end up on this particular issue.
Thank you both to our participants tonight and for you all for joining us. That's all we have time for. But tomorrow we'll be back. We'll have another briefing to give you the latest on the status of the launch countdown live on NASA TV. And until then, go SLS, go Orion, and go Artemis 1. Thank you and good night.